Maybe you're someone who doesn't want the privacy risks that go with ordering a retail hardware wallet. Perhaps you just don't want to trust any wallet vendors, or maybe you just like making things with Raspberry Pis. In this video, I'm going to be looking at building and using a Seedsigner. The Seedsigner is different to other Bitcoin hardware devices in that it's something that you're supposed to build yourself, just using generally available off-the-shelf components. It makes use of the Raspberry Pi platform, which means that the hardware and the software that it uses are very well supported. And if you're someone like me who's done a number of Raspberry Pi projects over the years, the only thing I actually had to buy was a couple of the display hats, and they're like 20 bucks each. So it can actually be a fairly cost-effective way to sort of dip your feet into the hardware wallet space as well. In addition to just doing a standard build with a Raspberry Pi Zero and case, I'll also be demonstrating building a Seedsigner using an original 2012 Raspberry Pi as well as a Raspberry Pi 4. And one of the other things I noticed along the way is a number of folk who have been trying to build Seedsigners have been getting into issues with the sort of physical build side of things. So I'll also be including some debugging steps along the way as part of this process. So this is definitely one of those videos where you're going to want to use these sort of chapter markers to sort of focus on the bits that you are interested in. If you haven't already done so, hit subscribe, and that way you can stay in the loop for content I make to help you find your way in the crazy and often hostile environment that is cryptocurrency. In terms of the hardware you need, you can gather the parts yourself, including 3D printing your own case or just running without a case. Or there are a couple of options, depending on where you are in the world, to be able to order it as a kit. And I've actually got one that I ordered here from BTC Hardware Solutions. Just came in a little box like this. The kit came with pretty much all of the components you need, plus an OpenPill case, some instructions on how to make one, as well as a Seedsigner sticker, though you will need to provide your own MicroSD card. It doesn't come with one. Anything over 4 gigs will do. Alternatively, if you have your own stuff, I've got here, for example, an old Raspberry Pi B, an old Raspberry Pi A will also work. Alternatively, if you have the parts lying around, any of the sort of Raspberry Pi cameras that just sort of work natively with Raspberry Pi OS are fine. So I had some of these kicking around from previous projects. This is a Raspberry Pi B, and this is a Raspberry Pi 4. And again, I've got a couple of the hats, though you will notice this one here for the older Raspberry Pi, I have actually had to modify it slightly because the GPIO headers are a bit different from the old Pis to the new ones. Fortunately, the pins on them actually have these lovely big solder blobs on the sides, so it's actually quite straightforward to sort of just solder some wires onto it on both sides. And what these wires are doing is essentially just relocating the pins for the buttons, because the pins for the screen are good, they don't need to move, but the pins to remap these buttons do. And you will need an adjusted version of the software for that. I'll be pushing that onto my GitHub and bringing a PR onto the main Seedsigner repository. I've actually found that these sort of double stacking connectors are actually very good in terms of being able to get enough clearance to be able to fit onto the I/O of these without having to remove the composite video connector. If you're someone who just has a standard Raspberry Pi with the standard 40-pin GPIO header, you know, the standard software and the standard hardware for Seedsigner will just work, and you can just use it with the standard camera module and you're onto a winner. The other thing that's important to note is this Raspberry Pi Zero I have here actually has the GPIO headers lovingly pre-soldered onto it. Unlike the larger Raspberry Pis, these small Pi Zeros don't come with these headers soldered on by default. So in terms of the Raspberry Pi Zero, if that's the hardware you're using, you will need to either buy one with the pin headers already soldered on. Alternatively, you could just solder them on yourself if you're not worried about that sort of thing and have the hardware to do it. Alternatively, you could use a product called a GPIO hammer for these Raspberry Pis. But before we physically build anything, we want to put the software we need on the microSD card. You also need a way to write software onto the microSD card, so any sort of microSD reader will do for that pretty much. And firstly, we are going to download the image file. There we go. And we're also going to download the Etcher program. That's the software we need to write the image file onto the SD card. So it's a free download, and we'll just download and install that. Now, once we've downloaded the file, we want to verify it. Now, look, you can just use the sort of browser-based option right here where you just sort of select the download file. The problem in this situation is that if you were on a malicious version of the Seedsigner website or had some other malware on your system that was tampering with the web page as you were viewing it, this verification here could actually be faked. So you're far better off actually verifying it properly against the GPG keys that are released by the Seedsigner developer. If you scroll down a bit further and actually go to the latest release page, so you can not only download the Seedsigner image, that's the big one we just downloaded, but you can also download these two files here, and they will essentially allow you to verify the integrity of the Seedsigner image, regardless of whether you had accidentally landed on a malicious version of the seedsigner.com website to start with. So we'll just download these as well, just into the downloads folder. And the other thing we are going to need is the actual developer's key. So we are just going to go back to seedsigner.com, and we can actually download the GPG pub key as well. So we'll just save that in the downloads folder. So these are the 4 files: the image, the files we need for verification, and the Seedsigner pub key. Now, to use these files, you're going to have to install GPG for Win, and you're going to have to import the Seedsigner public key, and also verify that the developer's public key matches this fingerprint here. The process for installing GPG for Win and importing a developer key is actually covered in this video here. It's a bit older now, but the process hasn't really changed. So once we've got GPG for Win installed and this developer key imported and certified, we can actually just right click on seedsigner.image.zip.sha256.sig file. And on Windows 11, we can actually just say open. So what it is doing there is verifying that this file here is intact and has been officially signed by the developer. And this file here basically just has the SHA-256 signature of this file. And then for the image file itself, we can say show more options. If you've got 7-zip installed, you can just do a SHA-256 straight from the context menu, or we can go down here and to just create some checksums. It'll just take a minute. There we go. So that's done, and it spat it out in that file there, and we'll just open that in Notepad++. So we can actually see now that my local SHA-256 sum is the same, checksum is the same as the one that is provided by the developer. So there we go. It's a little bit more convoluted than something like Electrum, but that's how you do it. So once we have verified everything, this file here is the image that we want to put onto a microSD card. And over here, we have our microSD card, so I'll just stick it in my little generic reader that I've got, and we'll just plug that into a USB port. We're going to open Balena Etcher, and we're going to say we're going to flash from file. We're going to select the Seedsigner image that we downloaded. We'll select target, and that's the microSD card that we plugged in just there. So I'll just say that one. Now, it goes without saying you need to make sure you have the right device plugged in. So this is probably a good step if you've got any other random USB sticks or other sorts of things plugged in, especially ones that are the same size as your microSD. You know, just unplug them so you don't accidentally go wiping your memory cards or other SD cards. Anyway, you have been warned. And we'll just say select, and we will say flash. All right, and that is done. One thing I'll just add at this point is it's not uncommon to have issues on Windows where it might fail to flash the memory card. You know, the software might just lock up, or maybe it'll fail at the verification step. You know, I've had these issues, you know, just randomly over the years on different Windows PCs with different flashing software, and most of the time it actually will come good if you just reboot the system and try again. First thing we're going to do is we're going to stick this microSD card in here. That just goes in like that. And now the second thing we want to do is we want to connect the camera. So the camera goes into this adapter here. This is the CSI port on the Raspberry Pi, and you'll see it actually has this sort of black clip across the top that actually slides out a little bit. So once we pull that out, in this instance, we want these shiny bits facing down. So we'll just slide the camera in. So you can actually just see it sort of just slides in to that plug like that, and then there's still a little bit sticking out, and then basically we just clip these bits down on the sides, push them in, and now that is in, it won't come out. So if you've got a normal Raspberry Pi, not a Zero, it'll be the CSI port up here near the Ethernet port, because there will be two plugs that look similar. So basically you just pull the retainer out just in the same sort of way, stick it in with the shiny bits facing away from the Ethernet port. Now before we go any further, I'll just show you to verify that you flashed the SD card properly, that your Raspberry Pi works, and that the camera is connected correctly. And for that, we're going to connect this up to a monitor and a keyboard. And there are two additional parts we're going to need for that. Firstly, we're going to need a display adapter. So for the Raspberry Pi Zero, that is a mini HDMI to HDMI adapter. Any will do. And we will also need a micro USB OTG adapter. This is just a really tiny one that basically slides into a USB port itself. What sorts of adapters you need, if in fact you need any at all, will depend entirely on what model of Raspberry Pi you have. If you want to pick some of them up and help me out in the process, I'll have some Amazon affiliate links in the description. We're going to use our micro HDMI adapter. We're just going to connect that here. And that gives us just a standard HDMI output. We can just connect that to any normal screen. We can just stick this sort of wireless keyboard receiver just in here on the middle micro USB port. This edge one's only for power, so you've got to make sure you get the right one connected. And we'll plug in the lead we're going to use for power. So once we've got everything connected like that, we can actually just power it on. See the lights flash, then we'll get that rainbow thing on the output. And then we'll see the sort of standard Raspberry Pi Linux boot sequence. And the reason why we see this is because the Raspberry Pi is actually running a full Linux distribution. It's basically an entire little PC just running on the Raspberry Pi Zero, and the Seedsigner software is just running on top of that. Okay, so that has booted up, and then once that has done so, we can actually just log in using just the standard Pi username that's standard for like Raspberry Pi OS across the board. So the username and password for the release are here. So that's that first part is the username, this last part is the password. But there's a bit of a catch when you go to enter this in. That's just timed out, but this is actually good to show you what I mean. So if I just type in air gapped, so AIRGAPPED, exclamation mark, you'll notice that the @ symbol has not worked correctly. That's because this is a US layout for the keyboard, whereas these Raspberry Pis, just because it's all an English thing, ship with the UK keyboard layout as the default. So if you're someone who's been playing around with Raspberry Pis for years, you would strike this all the time. If in doubt in terms of how your keyboard layout is being picked up, just try and type in the password as the username, just like I have here, and you'll see what's happening. In this instance, the issue is the @ symbol, and it actually corresponds to this symbol here on a US keyboard. So if I just type in Pi as the username, type in air, and then gapped, exclamation mark, enter, there we go, it's going to log in. So we'll just give that a sec to log in. So if your Raspberry Pi boots up, even before you log in, you verified that the microSD has been flashed properly and that your Raspberry Pi itself is working correctly. So what we'll do now is we'll also just check the camera, and we'll just, for that, we'll just use the standard Raspberry still command. So I'll just type that in here. So Raspberry still, and I'll type in -V, which means it's going to turn it on as a video camera. And if I hit enter, it'll actually run as a video camera for a few seconds. And I'll just show you that in full screen. And if I just hit enter, we can actually see that that's actually running. Whoop. So always check your stuff. So when I was debugging it, turns out this was okay, but this camera module that came with it seems to have failed, and I'll work out why exactly that happened later. But anyway, I swapped it with another camera module. This is a Raspberry Pi camera module 2.1, but the form factor is the same, the screws are the same, and this adapter lead here works just fine. So cannot emphasize enough, test this works on your bench before you put it in the case. So back to where we were before. So we'll put the hat on. Now let's power it up with the screen on. Okay, so we can see as soon as we connect the power that the backlight lights up, and now this is going to take a while. While it's booting up, you'll actually see the little green light sort of flickering away in there. That tells you at least that something's happening in terms of it reading off the memory card. Okay, So we'll just go back into settings and we'll do the full I/O test. So we can check that everything's still working, didn't break anything inadvertently in the meantime. That button works, the camera works. Just taking a picture of my hand, there we go. And we'll just exit back out there. So this all works, so that's great. So let's just go back up and we'll just power off. Again, this is important. So we'll just wait for about 30 seconds for that to power off. Okay, and we can actually see here that little green light has gone out, so that means it's ready to unplug. So let's unplug this. Now I'm going to unplug everything and we're going to put it all in the container. We've disassembled everything and we're going to snap it all into place here, starting from the bottom and working our way to the top. So we're going to start off with the camera module. So that is just going to sit in there, and there's actually some, you can actually see some little tiny clips that it's going to sit under. So let's give that a go. So we'll put that camera module in, and okay, so that's snapped into place. So we've got a bit of excess cable here on this. That is going to go in like that. So we'll just put that over there, bearing in mind we don't want to crush it too much. So we'll just pull that clip out and we'll seat that back in. There we go. So what we're going to do is we'll start that, sit that just there. We'll just tuck that in under there. We have to fold a bit of this excess in over the top because we don't want this obscuring where the microSD card goes in. So we're just going to fold that through that way, I think. And then just sort of sit that in there. Oh yeah, that works. So we've just put it in on the, put the ports down first. We've got a little bit of CSI cable sticking out, but we put the ports down first because we're going to get under this first row of things, and we want to make sure these all line up correctly and can sit and push down that way. So let's see, we've gone past, we've cleared those. We're just in line with the retaining clips on that side, and let's just push that down now until we get it in. There we go. Click. Definitely a bit of pressure needed for that to happen. So that's not coming out. Now, just because I'm paranoid, let's just put this micro SD card in and let's just check that everything is actually going to still work. There we go. So everything is working even though it is in the enclosure. Let's power it off and let's stick this top hat on here, just because once we put that on there, there is no way any of that's coming out. Alright, so we can just unplug this. That's not needed anymore. We'll unplug that and we'll just unplug that so it's easy to work with. So let's just put this back in here. So we've got to line it up with the pins. So again, the case sort of does that for us. And so I can feel it now just resting on the pins, and I'm actually just going to press it down onto them now. You can see the screen was slightly sticking out, whereas now it's pushed down and it's sitting on the mounts that were sticking out here. So that's now on the Raspberry Pi on one side, and then on the other it's nice and firm. So that's a good little unit. So moment of truth, let's turn it on with the everything all assembled. Oh, that's nice. You can actually see the green status light through that little hole. So that's handy. So let's have a look at actually using the device. So we've got our little Seedsigner here. So what we'll do is we'll go into Seeds. We can do Seeds in a few different ways. So firstly, we can scan a SeedQR. That's essentially a way we can store the seed in the QR code. We can enter a 12 or a 24 word seed, or we can create a seed. Now, before we go any further, it is worth being really clear that the Seedsigner is a stateless hardware device, and that's very different from almost every other hardware device you've ever used, in that the Seedsigner does not retain any of the private keys or seeds or anything like that that entered into the device. They are wiped every time it is reset. And this is why it is a really useful device for if you're wanting to sort of store and hold over the long term, and also why if you're someone who wants to transact maybe a bit more often, you can store your seed not just as the 12 or 24 word mnemonic phrase, but as a SeedQR, meaning that you can have a special QR code that you can just scan with the Seedsigner to reinitialize it with a given seed. But let's just start from the beginning. Let's say create new seed. You can create a seed which gets its entropy from the camera, from some dice rolls, or you can just pick the first 11 or 24 words and it will just calculate the last word for you. But because it's fast, we'll just use the new seed via the camera method. We'll just take a picture. There we go. We just click the joystick. There we go, and that's just an image of the Raspberry Pi A running the Seedsigner software. So we'll just accept that image. We'll just have a 12-word seed, just because it's faster for this example. Though it is worth going for a 24-word seed, just because the checksum is that much better in a 24-word seed. Never mind the advantages that I cover in this other video here. So there is our 12 words, so we'll just write those down. We don't want to skip verifying the backup. Whenever your hardware wallet gives you an option to verify a seed that is generated, you need to do it. Your seed is your wallet, so do not skimp on verifying that it is correct. There we go, backup verified. So that is great. This is our seed fingerprint. Now, this fingerprint isn't needed to be part of your backup, but this fingerprint allows us to uniquely identify this seed and make sure we have the right one. You can also add a BIP39 passphrase if you want, but we're not going to worry about that. So now we have our seed, and that is great. And to be able to use this seed, we also need to use this with a separate wallet. Now, I'll just demonstrate this using Blue Wallet, just because Blue Wallet is quite user-friendly and is available on both iOS and Android and works really nicely with the Seedsigner. So, I've just got Blue Wallet here on iOS. So what we're going to do is we are going to say we're going to add a wallet on here, and we are going to say we want to import the wallet. And what we're going to do over here on this Seedsigner is say export xpub. We just want single sig, and we'll just use native segwit. We'll select Blue Wallet. Yes, we understand there is a possible privacy leak there. Okay, so there is our xpub. So that's going to show us a nice little QR code, and over here on the phone we can say scan or import a file, and we will just scan that one there. There we go. The wallet has been successfully imported. So it's currently a watch-only wallet. Okay, so now in Blue Wallet, if I want to receive some Bitcoin into the wallet associated with this, I can just say receive. And if I want to verify that that address does belong to my wallet, just to make sure that the wallet software I use isn't screwing with me, I can just scan the QR code straight from Blue Wallet, the receive address. And then it'll say verify address, select seed to verify. I'll say it's that one, and it says address verified. So it receive address 0. So basically what this has done is just allow us to be doubly sure that this address we can see on Blue Wallet does belong to our Seedsigner. Okay, so I'll just send some Bitcoin there. All right, so that's how we receive some coins. And I'll show you how to send some funds. So we're just gonna head over to the Seedsigner donate page, because supporting open source matters. And let's just do that here. So there we go, awaiting payment and funds. So I'll just say send. It'll say this wallet is not being used in conjunction with offline signing. Do you want to enable it now? We will say yes. And we will scan the address straight off the donate page. There we go. We'll say next. Okay, so basically we've got our transaction here. So what we do with that transaction is we go onto our Seedsigner, we say scan, and we just scan that animated QR code. That's done, and we just choose the seed we want to sign with, so we'll say this one here. So that is our PSBT file. So what we're seeing here, and we can just verify that it matches. So we'll say next, and then we'll say next. And then we'll say approve PSBT. So now we want the signed PSBT for Blue Wallet. So we'll click on that. Then we have this animated QR code. So we'll go back onto iOS. So we'll say we're going to scan a signed transaction. We'll just scan it off the Seedsigner. There we go. And basically, once we're done, we'll just say send now. There we go. So that transaction is sent and the invoice on BTC Pay Server is paid. We've sent that transaction, so let's just look at these SeedQRs for the backups for this, because this is stateless. So we'll just use the joystick to get out of that. So what we're going to do now is we're going to go into Seeds, and that's the seed we had in there, and we want to back up the seed, and we are going to export as a SeedQR. And what that's going to do is give us a SeedQR that we can transcribe onto a sheet of paper that looks like this. And the template for these is on the Seedsigner GitHub. If you scroll down a bit, down to here, and you can actually get the template that you need. So basically I've got the template here, and what we can see here is the different segments that we need to color in on this template here for them to match. And we can see this corner bit is already done, so we can just slide across and we can see where we need to put the spots. So I've actually just got a nice big fat pen pinched from the kids, and we're just going to put a big dot on each of the areas we need to color. We're done, and let's confirm the SeedQR just to make sure it does scan properly. There we go, success. They yield the same seed. And the good thing about this is you'll notice my spots here haven't exactly been precise. I actually made a mistake down here as well, but there's enough redundancy built into these SeedQRs that this was still able to scan it correctly. And again, I would suggest that this is not your only backup. You know, store your 12-word seed just as you would normally with any other wallet. So what we can do now is I'll just go here and just power the device off. And we're back. So what we'll do is, so now you'll notice if we go back into seeds, there's nothing there. So we can just say we want to scan a SeedQR, and we can just scan that one that we made before. And you'll see the seed here is giving us the same fingerprint. It's giving us the same fingerprint that we had before from the 12-word seed. So we can know that this is right. So we'll say, it's definitely worth writing the fingerprint down on here. So we'll say we're not using a passphrase, so we'll just say done. So now we can actually just send the remaining funds back to the tip wallet. So we'll sign it with that PSBT. Yep. Review the details, full spend, yes. Next, approve PSBT, Blue Wallet. So we'll scan the signed transaction again. Same process as last time. That said, sometimes I do find that phones can be a bit temperamental scanning, so sometimes you might need to just cancel it and try again. There we go, that's scanned almost instantly, and we'll just say send now. And that is done. So all those funds have been sent back out of this wallet. So there you go. As you can see, the Seedsigner is certainly not just a super straightforward device for everyone. It certainly requires a bit more technical commitment and persistence if that's something you want to use. You don't just sort of pick it up and use it just like a normal wallet. Likewise, the fact that it's stateless might also mean that other people find that it's not suitable for the way they're wanting to use their Bitcoin. But again, the fact that you can build a device like this using off-the-shelf components is a fantastic thing. Again, if you're someone who just likes doing fun projects with a Raspberry Pi, this can be a fun thing to try as well. And if you're someone who's interested in, a maximum level of privacy, this combined with something like a full node is certainly a helpful tool in that tool set. One of the biggest challenges if you're someone who wants to build a Seedsigner of late has been that getting a Raspberry Pi Zero has been a challenge, especially getting one for a reasonable price. But the fact remains that the power of this project is that because it's using the Raspberry Pi hardware and software stack, it's quite simple to grab just about any Raspberry Pi, even some of the really old ones, and actually have yourself a working Bitcoin hardware device, even if it's not necessarily in a neat little package like this. If you've had any experiences with the Seedsigner, or if you're trying to build one and you're stuck, definitely just leave a reply in the comments. I do my best to respond to all of them. And the other place to look if you are trying to build one and are stuck is the Telegram group for the Seedsigner. So anyway, hope that was helpful, and best of luck. Thanks for watching. I hope that was helpful. Hit like if you think that other people would find this video useful, and hit subscribe if you'd like to be kept in the loop about future content I make that helps people stay safe in the crypto space and to recover if they get into trouble. If you have any questions about this video or a topic that you'd like me to cover, just leave a reply.